Now we start chapter 4, and in chapter 4 we're going to be looking at several different types of linear programming problem, and each of them we'll set it up as an Excel model and use Solver to find the solution. Now we'll be looking at problems from different functional areas like marketing, production management, human resource management, and financial management. And we'll also look at one specific problem that is kind of unique, different from the other problems, and where we look at efficiencies of operations, then see how efficient a given operation is relative to other operations. So in each of these problems, we will, as I said, we will set up the model in Excel and run Solver. So let's jump into the first problem. The first problem is about a company wanting to decide their advertising strategy for the next season. And they're considering 8 different television shows, and they're listed here. And they're looking at their target audience in these 6 different demographic groupings. So each television show, how many million viewers you will have in each of these demographic groups are given in this table, and this information is available from industry groups and rating agencies and so on. And we also have the cost to run one advertisement, 30-second spot, okay, and the amount given is in $100,000. Now the requirement is that we advertise in these shows in such a way that in each of these demographic groups we at least get these many minimum required exposures. We want to have 60,000 viewers from this age group and 60 from this group and so on. So our problem here is to determine our advertising strategy, how many ads we're going to run in each of these television shows, such that these minimum exposure requirements are met and the total cost of our strategy is minimum. So let's take a look at the problem given in Excel. Okay. Now first thing we're going to do is to do some formatting so things will look nice. Now these column widths are different, so let's get the column widths all set up correctly. So let's see. Okay, let's do it this way. When we do it that way, then these labels get messed up. So let's do a wrap around of the labels. So highlight all the labels and do Control 1, or you can do click this little arrow here, and that will open up the Format Cells window, and go to Alignments, and you wrap text, and that will wrap text and make sure that this is right aligned. Okay, and let's put an underline, and this information is given, so let's color code that as given information. Okay. Now we can sum this column using auto sum, so that will give us the total viewers in each of those television shows. We can copy that. Now if we divide that into the cost, we'll get cost per million exposures. These are the million viewers, so for each million what will be the cost. Now let's wrap this, wrap text. Okay. Now here is the required exposures that we have to meet, and that again is given information. And we have to figure out what the actual exposures will be and the total cost. So we have to set up those formulas to complete the model. Okay. In this problem, we have to determine how many advertisements we're going to purchase and run. So let's highlight that, and this is your decision variable. This is what we have to determine. Okay, let's give a name for that range of cells. So, okay, now what be the actual exposures? Well, the number of advertisement spots we're going to run in each of these television shows, and that should be paired with how many millions of viewers we will have in each of those shows. So that times that plus that times that times that times that and so on, which will be determined using the sum product function. So we have seen sum product function before. So what are the exposures per unit ad if you run just one spot, and here is the number of spots that we're going to run. So when we copy down, the exposures per spot will change, but since we've given a name for the number of ads purchased, that will not change. So this is your actual exposures. Okay, right now, of course, we are not running any ads, so it's 0, but when we finish the model and run solver, you'll have actual exposures there. And we want to make sure that the actual exposures are greater than or equal to the required exposures. Okay. Now, what is the total cost? And that is a sum product of the cost per ad. Don't use cost per million exposures. This is just for additional information. So this is cost for one spot, comma. These are the number of spots we will be running. So that is the total cost. So let's give a name for this. And this is the objective function that we have to minimize. So let's color code that. And this needs to be minimized because it is cost. Now this is the actual exposures, and these are the required exposures. So when you control, click and drag, you can highlight discontinuous ranges at the same time. So now we'll give names for these two ranges. Okay, now we have set the model up. The next step is to run solver. So let's go ahead and run solver. Here we want to minimize the total cost, and we want to do that by using this as the changing cells. Okay. And the constraints are that the actual exposures are greater than or equal to required exposures, and that's the only set of constraints. Make sure that the unconstrained variables are non-negative, and we select simplex LP. We solve, make sure that solver has found a solution, and here is the least cost, and here are the number of spots we have to run. Okay, I know that these numbers are non-integer, which cannot be. So if we want integer answers for this, it's very easily done. All you have to do is to go back to solver and add a constraint that this number of ads to purchase is got to be integer. So highlight that, and from the center you select int. Okay, that. Now if you solve, you'll get integer answers.